This video provides a summary of the procedures used for determining the flexural strength of Portland cement concrete, also known as the Modulus of Rupture, AASHTO T97. This procedure is used in engineering practice for quality control and quality assurance of Portland cement concrete. When performing flexural strength testing, the following safety precautions are required: safety glasses, closed-toed shoes, and a hard hat. Additionally, it should be mentioned that at no time should the safety cage around the apparatus be opened while the machine is running. The following equipment, materials, and supplies are required for flexural strength testing: a 6-inch by 6-inch by 21-inch hardened Portland cement concrete beam, metal rollers, a plate, a marker, a ruler, a testing machine capable of applying a controlled rate of loading, a system capable of measuring and recording the ultimate load applied to the specimen. The beam must be set up in accordance with the AASHTO T97 standard, which calls for a simply supported beam with 2 load application points near the middle of the beam. Effectively, the beam will be divided into 3 equal parts, with the middle third of the beam lying between the 2 loading points. To begin, first mark the beam to facilitate alignment in the testing machine and record the distances between these marks. With the machine off, place the bottom rollers in the correct position. Next, place the beam into the device, taking care to center it under the loading head. Realign the bottom rollers as necessary. Place the top rollers and plate on top of the beam, taking care to align properly. Once everything is properly aligned, close the door to the safety cage, securing it with the pin. The TA will ask you to compute the proper loading rate in pounds per second that the machine must apply to reach the target pressure application rate in PSI per second. By reviewing AASHTO T97 in the lab manual, it can be seen that the specified loading rate should be such that the stress in the extreme tension fiber of the beam increases at a rate of 125 to 175 PSI per minute. Aim for the middle of the specified range, 150 PSI per minute. In order to achieve this target rate, the machine loading rate can be calculated as follows. The machine loading rate equals the rate of stress increase in the extreme tension fiber times the beam width times the beam height squared divided by the distance between the supports. For a 21-inch by 6-inch by 6-inch beam with 19 inches between the supports, as will be used in the laboratory, a machine loading rate of 1,705 pounds per minute, or 28 pounds per second, is required to reach the target rate of pressure increase. Take care to accurately measure the beam dimensions when estimating the approximate loading rate. Once calculated, the TA will input the appropriate loading rate into the testing software and begin the test. The computer will record the load applied to the specimen as a function of time. You will see an increase in load applied to the specimen up until the point of failure, at which time rapid failure should occur. Once the machine is turned off, take care to measure the location of the crack in the beam. This measurement will be important in determining which equation is used to calculate the modulus of rupture for the test. The modulus of rupture is calculated using the equations shown on the screen in accordance with AASHTO T97. Remember that the calculation of the modulus of rupture is dependent on the location of the failure of the beam. If the failure location is too far outside of the middle portion of the beam, this test will be discarded. See AASHTO T97 for further details.